Are smartwatches accurate? Hi everyone, I'm Keith. Wearable technology has become popular in recent years. Wearable technology, or wearables, are a type of electronic device that is worn as accessories alone on the body, embedded in clothing, implanted in the user's body, and sometimes even tattooed on the skin. The most well-known of wearables are smartwatches and fitness trackers, which have become very popular in recent years to use in real-time health monitoring. While many people recommending taking 10,000 steps a day, a May 2019 JAMA Internal Medicine Research article showed that only 7,500 steps a day are needed to lower all-cause mortality. So wearables help people count their steps and reach their health targets of 7,500 or 10,000 steps a day. The wearables have become more sophisticated with advances in science. Not only can they measure motions such as steps taken or distance traveled, but also calculate calories burned and measures vital signs such as heart rate, blood pressure, and blood oxygen saturation. The latest Apple Watch even claim that they can potentially detect irregular heart rhythms. According to the website Statista.com, the Apple Watch is the most popular smartwatch on the market and has a market share of about 30% in 2021, about 3 times as popular as the next popular brand, which is the Samsung Galaxy Watch. Look, here's my Apple Watch 4. It is not the latest edition, but it certainly has many functions. For example, it can calculate the time that you have exercised. So you may ask, how do these smartwatches and fitness trackers do all that? Well, these wearables have sensors for motion, light, magnetic fields, and other physical or health measures. They also have a microprocessor, like a mini computer, that can collect data on our daily activities and process them either in the device or after transmitting the data over Bluetooth or Wi-Fi to mobile devices or computer using proprietary computer software. Most of the motion sensor in wearables are accelerometers and gyroscopes. Accelerometers are force sensors that detect linear acceleration of objects, and gyroscope detect angular and or rotational acceleration along one or more directions. Very often they are triaxial for 3D measurements, unlike the old-fashioned pedometers or step counter, which uses a spring-loaded mass or some other switch mechanism to detect the obvious impact produced by steps during locomotion. Accelerometry also measures accelerations, which is proportional to external force, and hence can reflect intensity and frequency of human movement. Accelerometers have a mechanical sensing setup that consists of a reference mass attached to a suspension system in a reference frame. Forces due to acceleration or gravity will move the mass according to the Newton's second law. F net equals to mass times acceleration. The acceleration can be measured electrically with the physical changes in displacement of the reference mass with respect to the reference frame. The data from the accelerometers and the time measurements can then be used to calculate velocity, acceleration equal change in velocity over the change in time, and displacement information, displacement equal to velocity times time, or numbers of steps taken. The displacement or number of steps taken can then be used to estimate calories burned. The data from accelerometers and gyroscopes can also be used to determine orientation of bodies and to detect force. Each maker of smartwatches and fitness trackers have their own proprietary software and algorithm to analyze the data collected to generate the steps taken, calories burned, or the outcomes of interest to the consumer. So they are not all equal in how accurate they detect motion or either calculate outcomes of interest. If you want further explanation of how wearables monitor physical activities, I would refer you to an August 2010 review article in the journal Sensors written by Yang and Su. So the physics behind the motion sensors of smartwatches are not so difficult to understand. But are their measurements accurate? Let's do some experiments with my Apple Watch 4 to find out. I'm going to make a fixed number of steps, let's say 50 steps, and see if my Apple Watch counts them correctly. To make them more interesting, I'm going to take those steps in 3 different activities. I will walk, run, and then climb steps. Because the major brands have good reputation, they have spent a lot of money and time developing their products. The smartwatches are probably reasonably good, or else customer would have complained and they would not be so popular. A 2016 PLOS medicine paper found that the smartwatches and fitness trackers had good correlation between the measured step count and the true step count, ranging from 0.67 to 0.88. So if I have to guess the results of my experiments or to have a hypothesis, I would guess that my Apple Watch is fairly accurate in counting my 50 steps. Maybe miscounting by less than 20% or plus or minus 10 steps. I'm now outside and I'm going to do some experiments to see how accurate my Apple Watch is in counting the steps that I've taken. So first, I'm going to walk 50 steps on a flat surface in a linear direction, and I'm going to count those steps aloud. Right now, my Apple Watch says I have walked 3,215 steps. The watch says I have got 3,264 steps. So they have counted 49 steps. Next, I'm going to run 50 steps and I'm going to count those steps aloud. The baseline steps that I have are 3,322 steps. Let's get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So, let me refresh it. So right now, the Apple Watch says I have 3,392 steps. So which means it has increased by 70 steps instead of 50 steps. I will climb up 50 steps and count the steps aloud. So the baseline steps that I have is 2,377. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So right now I have 2,418 steps. So I was partially correct. My Apple Watch was really good at detecting my steps when I walked and even when I climbed stairs. It was right on for my walking 50 steps and only off by 1 step when I climbed stairs, detecting 49 rather than 50 steps, but when I ran, it was off by a lot, about 40%. I actually ran 50 steps again, but then the step counted with that trial was off by even more, almost 100%. I think what is happening here is that if Apple relies heavily on acceleration to calculate steps taken, then running, which has more acceleration than walking, will make it overestimate the number of steps taken. Alternatively, if Apple takes into account the time spent, then running 50 steps took less time, and so it could affect the numbers of steps estimated. I wonder if Apple or other users know about this running steps not being very accurate, and whether Apple has improved their more recent versions of their Apple Watches. After all, Apple Watch is expanding into measuring other more important health measures such as heart rate, heart rhythm, and so they better be very good and accurate about those things. Well, in summary, I think I can trust my Apple Watch to help me to keep track of my walking and steps taken. But we'll keep in mind that it may not be very accurate when I'm running. Also, I don't know if I could trust it to measure my heart rate or heart rhythm. Maybe we need to do more real-life experiments next time. Bye for now.